Okay, so here's something that properly surprised me this week. AI test generation actually works now.
Define works.
Right. Fair. So a year ago, this was basically fancy autocomplete. You'd get test suggestions that looked plausible but verified nothing. The code compiled, it ran, but it didn't actually check if your functions did what they were supposed to do.
I remember those. Client sent me one. Test passed, app crash. Not helpful.
Exactly. But there's this new comprehensive guide out comparing the actual tools, and the gap between what works and what doesn't is enormous. CodoGen is leading right now. Multi-language support, Python, JavaScript, TypeScript, Java. But here's what makes it different.
Behavioral analysis.
Yes, it's not just pattern matching on training data, it's understanding what your functions actually do. And teams are reporting 40 to 70% faster test coverage than writing manually.
And the tests catch real bugs.
On first run, that's the bit that matters.
There's another one worth mentioning, Diff Blue Cover, for enterprise Java teams. Fully autonomous test generation. You point it at a legacy codebase and tell it your coverage goals. It handles the rest.
Wait, no developer interaction?
None, that's the promise anyway.
Okay, but here's what I keep coming back to. If you're still manually writing unit tests for greenfield projects, you're burning time you don't need to burn. The tools have caught up, but not all tools are equal. Some are still generating boilerplate that compiles but tests nothing.
So, how do you know which one to use?
Actually run the tests, see if they catch real bugs. Don't just check if they compile.
That sounds obvious, but most teams don't do that. They see green check marks and assume it works.
Yeah, I've seen that. Test pass, production breaks, not the same thing at all.
Right, so if you're evaluating these tools, be skeptical, test the tests. What do you think? Are you using AI test generation yet? Let us know in the comments. Okay, completely different corner of the tech world now.
Quantum.
Yes, and this one properly worried me. Researchers just confirmed something the quantum community has quietly worried about for a while. The simulators we use to test quantum algorithms are fundamentally broken.
Broken how?
394 confirmed bugs across 12 open-source quantum simulators. And here's the scary bit. These aren't bugs that crash the system. They're silent failures. The simulator runs. It produces output. The output looks plausible, but it's wrong.
No warnings, no error messages, just incorrect results.
Oh man.
Think about what that means for a second. If you've been validating quantum algorithms against these simulators, you may have been validating against phantom behavior. The gap between what you think your quantum code does and what it actually does becomes impossible to measure.
This matters because simulators are the ground truth for early-stage quantum algorithm development. When you can't run your code on actual quantum hardware yet, the simulator is all you have.
And if the simulator is lying to you silently?
You're building on quicksand, exactly.
The researchers found bugs across all 12 simulators they tested. Some produced mathematically impossible outputs. Others gave different results for the same input depending on how you structured the query. And nobody knew, because the output looked reasonable.
That's what gets me. It's not that the simulators are obviously broken, it's that they fail in ways that look correct.
So, what do you do if you're working in quantum right now?
Don't trust a single simulator, cross-validate against multiple tools, and even then, assume your ground truth might be wrong.
Because right now, it probably is. Right, let me lighten things up a bit.
Please.
Microsoft and NVIDIA announced a partnership this week. They're deploying AI and digital twins across nuclear power projects. Now, I know what you're thinking. Nuclear and AI, what's the connection?
Yeah, that was my exact thought.
Here's the thing. Nuclear power has a massive infrastructure problem that nobody talks about. Permitting and construction bottlenecks. Nuclear projects take 10 to 15 years from planning to operation. Most of that time isn't the actual building. It's regulatory approvals, environmental impact studies, safety reviews, mountains of paperwork.
Microsoft and NVIDIA are betting that AI can compress that timeline. Digital twins to simulate operational scenarios before you pour concrete. AI to analyze regulatory requirements and flag issues early.
The idea is, if you can catch problems in simulation before they become real-world delays, you save years.
And with the energy demands of AI data centers growing the way they are, nuclear is back on the table as a serious option, but only if you can make the economics work.
And the economics don't work if every project takes 15 years.
This is Microsoft solving a problem they're about to have. They need reliable baseload power for their data centers. Nuclear provides that. But not if it takes a decade and a half to build, cut that timeline in half, and suddenly the maths changes.
Worth watching. Okay, so this next one. Honestly, this one made me a bit uneasy.
Go on.
There was a GeekWire AI summit this week, and the speakers got honest about something the industry doesn't talk about much. The true cost of AI adoption. Startups running on subsidized credits from OpenAI and Anthropic. Engineers burning $5,000 in tokens over a single weekend. And OpenAI shutting down Sora. their video generation tool, because it was costing $15 million a day to run.
15 million a day.
A day.
One speaker used the term watermelon metrics, green on the outside, red on the inside, companies showing impressive user growth and engagement numbers, but bleeding money on inference costs.
The subsidized credits are masking the real economics. Teams build on GPT-4, they scale up, usage goes through the roof, and then the bill comes, and suddenly the unit economics don't work anymore.
I've seen this. Client came to me last month with brilliant product, users loved it, but every new user was costing them more than they could charge.
That's the bit that really matters. A lot of AI-first startups are going to hit a wall when the credits run out. They've built products that work brilliantly, but don't make money at scale, because the cost of inference is baked into every request.
If you're building on someone else's API, you're building on someone else's cost structure. And if that cost structure changes, your business model changes with it.
So what happens when the subsidies stop?
That's what I've been thinking about all morning. Do we see a wave of AI companies pivot to cheaper models? Do we see a rush to on-device inference? Or do we just see a lot of shutdowns?
I think it's all three. And we're about to find out which company's built for sustainability and which one's built for the demo.
Yeah, that's the question, isn't it?
Okay, last one before we wrap. And this one's a wake-up call if you're running AI in production.
Security?
Security. Teleport just released a report on AI security. And the headline number is brutal. Enterprises granting excessive permissions to AI systems experience 4.5 times more security incidents than those that don't.
4.5 times.
Here's what's happening. Teams are deploying AI agents and giving them admin access because it's easier than figuring out the minimum permissions they actually need.
Oh, I've seen this. AI agent needs database access, so they give it admin, because it's faster than setting up role-based permissions.
Identity management hasn't kept pace with AI adoption in production. We're treating AI systems like trusted users, but they're not users. They're automated processes that can be compromised.
And when an overprivileged AI system gets compromised, the blast radius is enormous.
What really bugs me about this? Most enterprises don't even have visibility into what permissions their AI systems have. They granted access once during setup and never audited it again.
So if you're running AI in production, this is your wake-up call. Audit your AI permissions, apply least privilege access, and assume that any AI system with database admin rights is a ticking time bomb.
Because statistically, it probably is.
Okay, so there's one more thing I want to talk about, and it ties everything together.
Go on.
Mind Robotics just raised $500 million to build robots that can actually adapt. Now, I know, another robotics company, another big funding round.
Oh, here we go.
But hear me out, because this one's different. Classical industrial robots are brilliant at repeating the same precise task 10,000 times. They excel at that. But the moment a part is slightly misaligned, or the surface texture changes, or the task requires any kind of judgment, they fail completely.
That's why most factories still need human hands for the messy, variable work.
Exactly. Mind Robotics is building robots that can handle that variability. Dexterous manipulation in real production environments. And here's the bit that really matters.
They spun out of Rivian.
They have access to active manufacturing lines. Real production data, not simulation data. Actual data from cars being built right now, today, on Tuesday, at 3 a.m., when the humidity is 67% and the part tolerance is slightly off.
That's the flywheel.
Every robot learns from real production conditions, the kind of edge cases you can't simulate because you don't know they exist until they happen.
And that connects to something else I saw this week. There's a new benchmark comparing VLLM and Erlang for production serving. A developer built the same React agent and ran it under load on both engines. The results? Tool calling workloads run 71% faster on Erlang, but long context summarization is more stable on VLLM.
So the choice isn't about which engine is better, it's about which workload you're actually running.
And most teams don't figure that out until they're 6 weeks into production and wondering why their agent is timing out.
The thing I love about that benchmark is the specificity. Not SGLang is faster, that's useless. But tool calling is 71% faster. Long context summarization is more stable on VLLM. That's the sentence that saves your sprint.
If you're building agentic AI right now, that benchmark is the document to send your team. Links in the description below. But here's what all of these stories have in common. Mind Robotics using production data. The VLLM benchmark showing that workload matters more than engine choice. Even the quantum simulator bugs. They all point to the same thing.
The gap between prototype and production.
And that gap is closing. But only for the people who understand the constraints, who use real data instead of simulation, who test their assumptions against actual production conditions.
There's a piece by Adi Osmani this week about multi-agent coding systems, and what he says is, one coding agent is a prototype, A team of agents with clear roles is a system that ships. The shift isn't subtle. A single agent writing code is impressive in demos but fragile in practice. It tries to be a planner, coder, reviewer, and debugger all at once. Orchestrated teams with boundaries actually ship.
And that's the pattern everywhere right now. We're in this moment where the tools are good enough that one-person teams can ship things that used to take squads. But only if they understand the constraints. Only if they pick the right serving engine for their workload. Only if they use production data instead of simulation.
The people who win in the next year aren't the ones with the biggest models or the most compute.
They're the ones who understand the gap between prototype and production and close it fastest.
So, stepping back from all of that, here's what I keep coming back to. The tools are getting better. AI test generation works now. Nuclear projects might actually get built faster. Robotics companies are learning from real production data, but the foundations, quantum simulators, AI economics, security practices, are shakier than we want to admit. We're building faster than we're building carefully.
Something to think about.
What do you think? Are you seeing this gap in your own work? Let us know in the comments. We'd genuinely love to hear from you. That's it for today. All the links are in the description, including that VLLM benchmark and the AI test generation guide. And if you're not already subscribed, hit that button so you don't miss the next one. Oh, and quick mention, if you're building AI products and need the right people on your team, check out Atlas AI Talent. We're building a waitlist for companies and candidates who get this stuff. Links in the description. You can find more at luma.marbl.codes. Thanks for listening.